Hello everyone, and welcome back with Mrs. Struble. Today we're going to learn about perimeter and area of composite figures. We're going to discuss how to find them and also how to use grid squares to find or estimate them as well. So let's get started. The first thing we're going to do is discuss how to calculate the perimeter and area using grid squares. So here we have an arrow and it is drawn inside of a grid. We need to first estimate the perimeter of the arrow, and then we'll find the area of the arrow. When we estimate perimeters of figures in grids, it's a three-step process. The first step is to add up the horizontal and vertical grid line lengths all the way around the figure. So first we're going to count the vertical and horizontal lines, add them up. Then we'll focus on the diagonals and we'll add them all together to get the entire perimeter. Okay, here we go. Doing the horizontal and vertical lines. I like to have a starting point and then go clockwise from there. That way I know I'm not forgetting anything. So we have this one, which is a 1 unit length. We have this horizontal line, which is 5 unit lengths long. 2, 5, and 1. We do not have any more horizontal or vertical lines. So let's make sure we write them all up. 1, 5, 2, 5, 1. Add them all together to get our total horizontal and vertical lengths or perimeter of 14 units. Okay. This grid did not tell us what each square was equivalent to. So if we do not know the label, we still do not want to leave it blank. We just say units. And that's kind of just the universal code for, hey, whatever you want. Now let's calculate the diagonals. When we add up the diagonals, when we're calculating the perimeter, we need to keep in mind that each diagonal unit is approximately 1.5 units in length. Okay. So from one corner to the other corner of each unit square is actually 1.5, almost 1.5 units long. Okay. You'll learn more about this approximation or this length when you get to talk about the Pythagorean theorem in your geometry or maybe even your algebra class. For now, let's just stick with, hey, one diagonal unit is the same thing as about 1.5 units. So how many diagonal units do we have? 1, 2 over here and 2 over here. We have a total of 4 diagonal units. Each of those units is equivalent to 1.5 units. So 4 times 1.5, we get 6. Our third step is to take our vertical and horizontal units and our diagonals, add them all up. Okay. If you notice, we have outlined the arrow all the way around, which means we haven't missed anything. So that's a good thing. All right, so let's take these and add them up. We have 14 and 6, making for a total of 20 units. Again, perimeter is a one-dimensional measurement. Now let's take that same figure, but this time let's find the area. Again, 3 steps will do the trick. The first step is, when we have a grid, is to just count how many full squares are inside the figure. Then we're going to count how many half squares there are, and we're going to add those two values together. Okay? Excuse me. We're going to count how many half squares there are, divide that by 2, and then add the numbers we got from the step 1 and step 2 together to get the total area. So step 1. Full squares. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I count 12 full squares inside this figure. So there's 4 units, or 12 units squared. Okay, or 12 square units, you could think of it that way. Now let's count the half squares. Now each half square only counts for half of a square unit. We've got 1, 2, 3, 4 half squares. So we're going to take that 4 and times it by half, 1/2, or you can think of it as you're taking 4 divided by 2. All right, that's as easy as that. You're just taking 4 divided by 2 and getting 2 square units, which makes sense because if you put these together, 2, it gives us 1 whole square unit. Okay, and we've got 4 of them, so we get 2 square units out of it. Add them all up, add them both together. We get 12. We have 12 plus 2. That's a total of 14 units. Area is a squared dimension. Okay, it's 2-dimensional. All right. Now we've discussed how to do area and perimeter given a grid. Why don't you give it a try? Pause the video, give this a try, and I'll be back with your answer. All right, now that you've given it a try, let's take a look. When you estimated the perimeter and the area of this figure, you should have gotten this. The perimeter was equal to 31 units, and the area, it was equal to 51 units squared. If you missed something or got one of these wrong, pause it, try and find your mistake. Let's discuss how you would find the perimeter and area of a composite figure without a grid. Okay? So the first thing I'm going to suggest you do is deconstruct that figure. Try and figure out what that figure is being made up of. So in this example, we see the cone-looking shape here. Okay? And what we can do is kind of slice it down the middle here, and we have created a triangle with a semicircle, just kind of put together. Okay, that's deconstructing it. Now, using this, let's first find the perimeter, and then we can find the area. In order to find the perimeter is the distance all the way around. Okay, so we've got the base of this triangle and the height of this triangle. Those are easy measurements to follow. Again, I always like to just find a starting point and go clockwise from there. So we have 6 plus 8, but then we come up against a curve. Now this is part of our semicircle. So what measurement of a semicircle is it? Well, it's actually the circumference. And the circumference of a semicircle is the circumference of a circle divided by 2. Okay. So we're going to take the circumference, which is the diameter times pi. So we have a diameter here of 10. times 3.14 and divide that by 2. Okay. Well, I like to do the reducing here. Just makes it my life a lot easier. 6 plus 8, we'll go ahead and get that done and out of the way. That's 14. So we have 14 plus 5 times 3.14, 15.7, giving us a total perimeter of 29.7 feet. Okay. Now let's find the area. The area is everything inside. So in order to calculate the area of a composite figure, we have to first calculate the area of each individual figure, okay? And then we can add them together. So we need to find the area of the triangle plus the area of the semicircle. Again, here are your measurements. We've got the base of the triangle is 6, the height of the triangle is 8, and the diameter of the circle is 10. Substituting in those values, we have 6 times 8 divided by 2 plus, well, if the diameter is equal to 10, then our radius is 5. And 5 squared is the same thing as 5 times 5, which is 25. We're going to put in 3.14 for pi. And now we have values we can evaluate. Okay. So 6 times 8 divided by 2. Well, again, I like to reduce right away. Okay, 6 times 4, a lot easier for my mind to take, is 24. 25 times 3.14, that's going to get us 39 and 25 hundredths. Add them together, we get this. So our final answer is going to be 63 and 25 hundredths feet squared. Do not forget to label. Okay. Why don't you give this a try? Find the perimeter and the area of this figure, this composite figure, and round any values to the nearest hundredths. So pause this video, try it out, and I'll be back with your answers. Now that you've tried this, let's go ahead and talk about the answers. Once you've calculated this, you should have gotten a perimeter of 12 and 56 hundredths inches. And then the area was 10 and 28 hundredths inches squared. If you did not get this answer, please make sure you're pausing the video, trying to figure out, looking through your work and seeing where you made your mistake. If you're showing your work, you should be able to find your mistake easily. In this video, we talked about how to calculate perimeter and area of composite figures using just a picture or a grid squares. Thank you for joining me. Till next time, this is Mrs. Struble with Struble Math. See ya!